All right, lesson 2, union rule of probability and complements. If a card is chosen randomly from a deck, what's the probability it's going to be a heart or a black card? Okay. So a heart is a suit of which there are 13 cards out of the 52. And we say or, remember we're adding. So that's going to be black card, which is half the deck, 26 out of 52. And that equals 39 out of 52. Now we want to always reduce, so watch the little trick here. Very easy. We can do 39 divided by 52 and get our answer. Okay. And then you might recognize already that it's 3/4. But if we go to the math key, and right there where it says fraction, just hit enter twice, and boom, we get 3/4. Okay, so the calculator will reduce for you. Now, here's probability rule of union. So the probability of E or F is E plus F minus any overlap. So let's talk about that. If a card chosen randomly from deck, what's probability that's a heart or a jack? Okay, now hearts, we just said there's 13 of them, and jacks, there's 4 of them. All right, so we have 13 out of 52 plus 4 out of 52 equals 17 out of 52. And that's a big no. Okay, why not? The jack of hearts. That's a horrible heart. Okay, the jack of hearts. Because the jack of hearts is both a jack and a heart, so it is an overlap. So we have to take our 17 over 52 and subtract out that one card that is both a jack and a heart, and get 16 out of 52, which reduces to 4 over 13. All right, what about 8 or a black card? Okay, well, there are 4 8s. There are 26 black cards, but we have to take out the 2 black 8s. Okay, so this is 2 blacks and 2 reds. So we need to take those out. Now, of course, if you thought about that ahead of time, you could just put 2 over 52 here, but you may not always catch that right away. So this is the rule. You take out all the overlaps. And what that gives you is 28 over 52, which reduces to 7 over 13. Okay, 5 or a face card. Well, there are 4 5s, and there are 12 face cards. There are no, and we don't technically have to do this because this is like the first problem, there are no overlaps. So this is kind of like, number 1. There were no hearts that were black cards. So we didn't do minus anything, but this is just technically showing you it's minus 0. So it ends up being 16 out of 52, which is 4 over 13. Okay, now, do you have to do this part? No, just technically showing you how it applies to the rule. All right, mutually exclusive. So in the event of picking one card from a deck, then choosing a 5 and a face card are mutually exclusive because there is no 5 that's not a face card. On the other hand, picking a queen and a face card are not mutually exclusive because a queen is a face card. Okay, so if you're a 5, you can't be a face card, and vice versa. Okay, so in a class of 320 students, 300 have taken the ACT, 50 have taken the SAT. If a student is chosen from this class randomly, what's the probability he has taken both? Okay, well, if you take the total number of students minus the ones who have taken the ACT minus the ones who have taken the SAT, you get negative 30. That is the overlap. So we did a good old Venn diagram. So here's my ACT. Here's my SAT. The total is 320. Okay. And I have 30 in the middle. Sorry. 30 in the middle. Well, if 50 have taken the SAT, that's 20 who have just taken that. 320 minus, sorry, the 300 who have taken the ACT minus the 30 is 270. So that's our breakdown. So 30 out of the 320 is 7 out of 32. Now, do you have to do a Venn diagram for that? Not necessarily, but it does help show you what's happening here. Okay. 24 students who have taken math, 16 have taken science, 6 are taking both. There's 38 students altogether. What's the probability that someone has taken neither? Okay. Well, if you do 38 minus hold on. Just got something. Sorry, got ahead of myself. So if we look at this, Venn diagram is definitely useful here. So we have 38 students total. Okay. We know 6 are taking both. So we know the middle number. If this is our math, we know there's 24 students. So 6 from 24 is 18. And we know there's 16 taking science. This is our science. 16 minus 6 is 10. Okay. So if you add those up, that's 34. That means there are 4 students that are not taking either. All right. So if we did 38 minus 18 minus 6 minus 10, that's where we get the 4. Okay. So that means there's 4 out of 38. That's the probability who are not taking it, which is 2 over 19. All right. So last idea here is rule of complements. If E is an event, whatever the event is, then the probability of the complement, okay, is 1 minus the event. All right. So if you think about here with the deck of cards, right, 1 is going to be 52 out of 52. That's 1. So that's our representing our 1 here. Okay. So if a card is chosen from a deck, what's the probability that a card is not a king? So we take our 1 whole minus the probability of that event. There are 4 kings in the deck, meaning we have 48 cards left that are not a king. So that's 12 out of 13. So basically we're moving 1 king from each suit, so that's why it's 12 out of 13. What about letters? Well, 1 whole is going to be 26 over 26 because there's 26 letters. What's the probability that it's a consonant? That means it's not a vowel. So 26 minus 5 out of 26, A-E-I-O-U, equals 21 out of 26. So this one's kind of common sense. You're just figuring out what is not in that event. Now, what if we did A, E, I, O, U, and sometimes Y? Then that would be 26 minus 26 minus 6 over 26, which would be 20 over 26, which would be 10 out of 13. And that's it.